Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, I catch up with Sergey Gorbunov from Axelar. We revisit the topic of bridges and chat about what led him to work on interoperability. We then talk about the problems that Axelar is trying to solve, how it compares to existing solutions, and what's next for the project. This is one in a series of bridge and interoperability episodes that I plan to do for the next few months, so I hope you enjoy. Before we kick off, I want to just highlight the ZK jobs board for you. If you are looking to jump into ZK professionally, I want to remind you to head over to the ZK jobs board to find job posts from some of the top teams working in ZK. Find the next project or team you want to work with. I also want to encourage teams who are hiring to use the jobs board to find your next hires. We have great teams like Elio, Anoma, and Mina already there, so be sure to add your jobs as well. You should also check out our link tree. We have put together a list of a lot of the channels that we have. We are adding to it. But if you want to jump into ZK, this is probably a good place to start. So now Tanya, the podcast producer, will tell you a little bit about this week's sponsor.
Today's episode is sponsored by Polygon Zero. Polygon Zero is a layer 2 scaling solution for Ethereum. What separates Polygon Zero from other ZK scaling solutions is the power of Plonky 2, a groundbreaking prover system which generates ZK proofs faster than any other existing tech. Plonky 2 supports efficient recursive proof generation, allowing Polygon Zero to scale horizontally, meaning the throughput of the protocol is not limited by the weakest nodes on the network, but only by the total compute available. Visit polygon.technology to learn more about Polygon Zero and other Polygon solutions. So thank you again, Polygon Zero. Now here is Anna's interview with Axelar.
Today, I'm chatting with Sergey Gorbunov from Axelar. Welcome to the show, Sergey.
Hey, Anna. Great being here.
I do want to share this. The ZK Validator is an investor in Axelar. And what is interesting about when we actually did that investment, for me at least, that was, I think, the first time I saw a project that talked about this like multi-asset bridging technology. And I know you don't call yourself a bridge, so we'll get to the difference there. But back then, or when I first heard about it, it was for me the first time I'd even had really heard that concept. I know since then there's been a few more that have kind of entered the space with a similar thing. I want to get into sort of the competitive landscape. And just generally, I'm actually doing multiple episodes right now on these types of solutions. So I'm planning on doing one a month. So I'm very, very excited to be digging into this one, to Axelar, especially since I think this will be the first time I revisit since we spoke some time ago. What about you? Where are you coming from originally? What ecosystem did you start from?
Good. So I guess I started from a technologist ecosystem. How about that?
Okay.
And a cryptographer
Did you come from math then? You came more from academia potentially?
So I did a lot of things, I would say, prior to get into blockchain full time. I originally was very passionate about security and kind of practical security. So kind of concentrated on that during my undergrad. I loved networking. So I worked on software-defined networking. We were building distributed controllers kind of 10, 12 years ago with a couple of professors and students at the University of Toronto. And then I wanted to study formal cryptography, right? So I went to grad school, did my PhD at MIT. And then by the end of it, was a little bit bored from doing, again, pure theoretical research. So I wanted to do something more applied, started to play with blockchains, some of the early designs behind Algorand. And with Silvio and a couple other students, we helped to take that project from research to the market and taking the platform live.
Wow, wait, so you were one of the early Algorand folks then? You were there, were you part of that original team then?
So yeah, originally, the project started as me and Silvio doing some research at MIT, when I was finishing my grad school. Then I joined University of Waterloo for a couple of years. So the research around Algorand continued. So Silvio involved a lot of other students, kind of a faculty to help design, continue shaping the protocol. I think it's been through 4 or 5 iterations. And, eventually we got together as a small technical team in early, I believe, 2018. That's when initial funding was attracted to the project. And we kind of took that to the market.
What was the impetus to break out of there? Like, you'd been working in this project, now you're doing something that I guess could be used together with some of the work you did maybe, but what prompted the move?
So as we're building Algorand and as we shipped it to the market, one of the first questions that kept on coming up is, how do we bootstrap that ecosystem, right? And bootstrapping really came to bring in liquidity, bring in users, bring in some of the existing applications to the Algorand platform, right? And in the early days, when you ship something technically better without a community, that's a very hard problem to solve. And so we were looking for different ways to connect Algorand with other ecosystems, nothing that we could really apply and connect it that easily. And at the same time, myself and my co-founder Yorgos, we saw a lot of other just amazing projects being developed in parallel, right? Like Cosmos, big fans like Polkadot, right? Like Avalanche, Solana, Near, and the list goes on. Everybody had their own take on consensus. Everybody had their own take of what smart contracts should look like. And so it was clear to us that if the ecosystem continues to grow, all those ecosystems are going to have different applications, going to have users, and they're all going to have to talk to each other one day. And we wanted to bring this connectivity to continue accelerating the ecosystem and help compose all these different applications.
You just mentioned Cosmos, though, and Cosmos has IBC kind of, I think it's a pretty early part of the project. I think that was announced quite early on. Why wouldn't you have sort of pursued something like that, like a glue between networks like IBC?
So IBC, I think, is a great protocol, right? And I think it works quite well. It's very technically hard to apply to different consensus mechanisms. So, practically for us, like at Algorand, to apply something like IBC, we would have to pretty much rewrite most of the consensus because it works very differently. You have kind of randomized selection that allows validators to be selected from, anybody in the world in some sense. And so IBC requires you to have very effective and efficient light client implementations that need to be communicating across all of the different chains that you want to interact with, right? And so if you want to interact with, Cosmos ecosystem, with, Solana, with, Avalanche, you're talking about different consensus mechanisms that have to exchange light clients. You're talking about potentially different smart contract languages that need to support these light client implementations. And then you have to maintain these implementations every time you want to do an upgrade. And then you have to, recreate these connections all the time. So while, from a security perspective, I think it's a great protocol and has a lot of advantages. As an engineer and, especially some of the background around networking and things like that, I just knew that the friction that is going to continue, we're going to continue seeing to scale these protocols. That being said, I think, we'll see what happens, right? I think it's I think it's still early. We're still building some of these kind of core pipes and connectivity tissues and learning what works, what doesn't.
Okay, so let's talk then about this emergence then of Axelar. So I guess you left the org, started a new company. What did you set out to do at that beginning point?
Originally, we were actually thinking about some simple applications that would be great to build cross-chain. So, for instance, things like DEXs, right? Decentralized exchanges. Great use case, right now, at that time when we were thinking about it, things like Uniswap were coming to life, right? Lots of traction. So it was a very nice early use case for the blockchain ecosystem. And we thought, well, it would be so much better if it's cross-chain enabled, right? So being able to interact and swap assets from one ecosystem for an asset of another ecosystem, that would be amazing.
That's the dream, yeah.
Yeah, but what we realized is that to build an application like that, you're going to have to roll out so much infrastructure in parallel. Right. And then every single time you want to build an application that's cross-chain enabled, you're going to have to reinvent this infrastructure and whatever you're doing. And so it was clear that there was an infrastructure gap that just has to be solved with good, robust communication protocols, good, robust, relaying services, fee services, interoperability stacks, and that would enable and empower thousands and millions of applications down the line. To us, that was super exciting, I think, right? Working on the infrastructure, which we've been doing for years, and at the same time applying it to scale the whole ecosystem, what could you ask for more, right?
Cool. But so let's talk about this question of what you call yourselves, because I think you've been lumped definitely together with bridges. But I have heard, I think in even like a talk we did like for the ZKV Privacy and Cosmos, like previous online event, I think you did mention this distinction. You see yourselves not as a bridge technology. Tell me something about this distinction.
Good. So I think at the high level, the way to think about Axelar is it's a decentralized overlay network that's been designed sort of from the ground up to deliver Web3 interoperability. Okay. And so I think the basic core three properties that we're trying to implement at the network transport layer are things like universal routing, universal translation of messages as you go from like one ecosystem to another, right? And strong and robust security properties that the ecosystem needs in order to facilitate cross-chain communication, right? And I think, if you look at bridges, most of them been sort of rolled out as a one-off ad hoc solutions to solve a specific pain point, like transfer an asset from one ecosystem to another, and it sort of stops there, right? And I think what we're trying to do is build kind of a series of mega highways in some sense that would enable us to connect millions of chains down the line. And that requires a very different, engineering and infrastructure approach so you can continue scaling.
You sort of mentioned like routing messages. So this is a distinction between Axelar and some of the other bridge solutions. Last month, we did an episode with Gravity Bridge, and theirs is primarily token transfer. We talked a bit about messaging. And I wondered, like, when you say messages, is this like DApp calls? Like what are those messages? What do they look like? And why are they more complicated to translate than a straight up token transfer?
Good, great question. So when I say, I guess, messages, I'm really referring to an arbitrary payload that you can pass from one chain to another, right?
Okay.
And that payload can really encode any information that you want to be executed. Okay. A token transfer is a specific type of, request that you can transfer from a source chain to a destination chain. That request would encode information like, I locked my token here. Could you please mint, the corresponding token on this other chain for me, right? To execute that request, you need to, finalize it on the source chain, right? You need to validate it. You need to create a message that's posted on the destination chain that says that this request has actually been validated, right? So you can trust it. And then you execute that call. So I think that's a very simple use case for interoperability, but I think we want to go beyond that. In some sense, what we want to do is we want to be kind of a Turing complete platform, right, where you can build applications that are just as rich and powerful as you were to build them on a single chain, right? So you can encode arbitrary payload, NFT transfer, contract calls, lending and borrowing applications, and you can encode that as an arbitrary payload and get, the underlying infrastructure to securely deliver it to the destination chain and execute.
Is that a harder ask? Is that like a harder engineering feat to actually make it so generalized and not just focused on that one use case of tokens?
I'm not sure if it's, harder from an engineering perspective. I think it really requires you to think how to build the right system that scales, right? And how to build the right system that, when new connections are added, you're not creating like fragmentation across the ecosystem, right? How do you enable like universal routing across all these functionalities? So when a new chain is added, you want to make sure that other chains are sort of aware of the path from the source to the new destination chain without too much, engineering or interaction on the back end. So it's things like that. And then, definitely, I would say it actually helps improve overall security, right? When you deconstruct sort of the transport layer of interoperability with application-specific use cases, that allows you to focus and say, okay, I don't care what the messages are. I need that infrastructure to be as secure as possible. And then layers above it, in some sense, get to decide what to do with that information.
Or they read that info. They actually decipher it. So it sort of doesn't matter what's in there. It's just passed.
Yeah. And I think a good analogy is think about how you build on a single chain, right? You have a consensus where you can, deploy an arbitrary smart contract and you can write your instructions on top of it. When validators execute and sequence consensus messages, they just execute whatever you tell them, right? But the consensus itself is not specific to the application. I mean, I think Cosmos is a sort of an exception, right? Where the whole stack is designed, where at the consensus layer, you're sort of validating, the messages. But, a lot of the other platforms almost Turing complete in some sense, right? Where the consensus just sequences the messages and creates the order and structure. And then you can write an arbitrary logic on top of it.
And you're doing it that way. You're kind of, you're not looking so deeply at the use case with the use of the actual data.
I mean, for some use cases, you can do more interesting things if you look at the message and the payload. For token transfers, in particular, so we enabled one of these properties that I call like translation between like IBC token transfers and EVM token transfers, where you actually have to look at the message, in order to encode one format to another. But I think of those things as sort of optimizations in some sense that allow you to do more at the network layer.
When it comes to some kinds of information, though, like, do you need some sort of translator on either side? Like, some blockchains just work quite differently. So, like, are you acting as that translator between them? Or are you do you need to have access to some, almost like the lexicon of each one, and then you're, doing some sort of translation?
Great question. So I think this is one of the core properties that Axelar network provides at the network layer, right? Which is translation of different messages. So, as an example, when you send a message from a Cosmos ecosystem that is, let's say, an IBC token transfer, then at the Axelar network layer, we can take that message, we can translate it to a message that needs to be delivered to an EVM chain and execute it there. So the network serves as this translation layer. Now, you're right that every ecosystem speaks its own sort of language, right? Potentially has its smart contract. So you have to have this translation. And then you ask yourself a question, where's this translation going to happen? And there's pretty much two places where it can happen. It either happens at the application logic, right? Think of it like almost like at the smart contract close to your application, right? Or it has to happen somewhere in the transport network layer.
Yeah. One check here. If you did it the first way, would that be basically like almost like a light client on one side that does, I don't know if it would be called a light client, but some smart contract on one side that like gets it prepared in the format that you'd need on the other?
Yeah, exactly, right. Either on the source or on destination chain, you have a smart contract that takes a message, decodes it, right, deconstructs different payload, and then interprets it and then parses that, right? So yeah, that's if you want to do it almost like at the exit and entrance points, right? And sort of we do some of this functionality, at the network layer, which allows us to be a lot more efficient, a lot cheaper, right? Because, you don't have to pay like huge gas costs for doing these translation layers, and it allows us to continue scaling and add in more routes in a uniform way while just composing and building on the networking effects of the translation, right? So you change the model from having a peer-wise translations and peer-wise connections, right, to a model where everything is down at the route and transport layer. It's sort of in a more uniform and cohesive fashion.
Something that was highlighted kind of early on that was special about the work that Axelar was doing was the use of threshold cryptography. Is that what makes this more efficient or cheaper? Is that the secret sauce, or is that used for some other reason?
I mean, it's definitely one of the ways, right? The way we designed the whole system is to allow us to continue, scaling and making it cheaper and making it more efficient to deliver the messages, right, from one ecosystem to another. And so the cryptography component is almost a plug and play component on top of the Axelar network, right? So we can plug in threshold, we can plug in multi-sigs. I think we've done a lot of work on like standardization of BLS signatures, which I think is going to be, quite powerful for some of the chains that will support, BLS, and you can kind of continue down the line. And yeah, all of those primitives, they have their own trade-offs. Some of them more, efficient. Some of them are, have non-interactive compression mechanisms. Some of them are interactive. But the goal is to continue building the system and continue scaling it so that the translation, the message passing functionality can be cheaper and cheaper and cheaper over time. And there's a whole set of optimizations you can do. Threshold cryptography is definitely one of them.
But you just mentioned a few different types. So you sort of mentioned the sort of multi-sig version, but that makes me think it might be good for us to explore actually what is happening under the hood in Axelar. Like, are there a bunch of different pairs that you've created that are like moving between the two two different chains? Or is it, because when you say that a multisig, I think of the more primitive bridges that do exist today, which is like a multisig connecting two networks, basically locking funds on one side to mint funds on the other, and then burning them and bringing them back and unlocking them. But Axelar doesn't do that, right? Or is it like every single connection has, a unique bridge format?
So let me kind of take a step back, right? And like let's talk through high-level architecture, right, of the Axelar network.
Sure.
So the high-level architecture is the following. On different chains that we connect in, we have, a notion of a gateway account, right? Or a gateway smart contract. Think of it that way. Okay. So, on EVM chains, that's a solidity contract. Mm-hmm. So what this contract exposes is a certain API that as an application you can call to deliver a message to a destination chain that you want to talk to. Okay. Now, underneath all of this is the set of Axelar validators. Okay, it's a permissionless set of validators built around Cosmos SDK, where anybody can join and participate as a validator. And so collectively, what the validators do is that they observe these bridge accounts, right? And they observe messages that are posted to them. Once they see that a message is posted, they execute a consensus to reliably, verify that message and then process it. Process it here means, figure out where it needs to go. So that's routing. Translation, if it's a message that needs to be sent for an IBC chain, you actually have to take it and translate it to an IBC packet, for instance, right? And then sort of execution. And the execution means that they collectively authorize a corresponding message to be marked at the destination gateway as approved by the Axelar network, right? And so this last step is where, again, like you need a consensus of and a majority of the validators to approve that message. And to do that, you can have them either post their individual signatures, or you can run, threshold cryptography to generate one signature collectively, but it all serves the same purpose, where the majority of validators reach a consensus and the threshold of them authorizes the message. And now it can be delivered to the destination, chain or gateway. And from there, applications look at the gateway and say, has Axelar approved this message, right? Yes, Axelar validators have approved the message. The majority of them have, co-signed it or posted individual signatures or one signature. And then, therefore, I'm going to go and execute it. So that's the high-level architecture. So from an application perspective, you now get to build your application on any chain that you like, right? You pick your home base, what I call, and from there you get to interact with other chains by just talking to the gateway. So you don't have to learn Axelar stack, you don't have to understand how relaying is done or anything. You just talk to the gateway. That's a regular Solidity message, or if you're on the Cosmos chain, you will talk like IBC and go from there.
When you talk about these validator sets, it just made me think, like, is there MEV on these things as well? Is that also where the threshold cryptography could come in handy to prevent, because it's hidden a little bit? I mean, at least I know, threshold decryption used in the context of MEV, but I don't know if that's how you're thinking about it.
That's not how we're thinking about it. Like here, we're using the threshold signatures, I guess, for validation. But you are right that threshold cryptography can help you against other types of attacks, right? Sequence a set of messages without validators seeing what the messages are, like through threshold decryption. We actually have kind of a short paper coming on this shortly, how to do it like more effectively with things like identity-based encryption. You get to save a lot of traffic at the network layer. And, you can definitely do it. And I think just having validators that have secret keys that you can do something cleverly with opens up all kinds of optimizations of this transport layer and better security down the line.
Got it. But back to MEV, are you worried about that? Is that something to worry about?
Am I worried about it? I mean, I am, but it doesn't prevent me from sleeping at night in some sense. It's okay. So kind of stepping back, right? To do the interoperability the right way, it's actually very important to make sure that you don't have order dependence of the messages as you moving them around.
Okay. Why would that be a problem?
Good. So the point is that whenever you're talking about very different environments, 100 things can go wrong. Okay. And then if you have a system that has synchronous communication across different hubs of connectivity, then there's just so many places where things could go wrong and break, and you're going to be stuck without a system that doesn't make progress. So the right way of doing this is to design a system that in some sense has, think of it kind of a IP or UDP level of message passing, right? So these are kind of protocols on the internet where you don't have a lot of properties in terms of the ordering of those messages and how they arrive. But on top of it, you can build application-specific protocols that have stronger properties, right? So for instance, you can have protocols that have sequence numbers that only make sure that before the messages are played on the destination chain, they need to arrive at a certain sequence at the source chain. Right. But all of that you can build as application layer protocols on top of the infrastructure that needs to remain robust and secure. And so if you start mixing these things up, which is I think a lot of projects have been doing, you're going to run into all kinds of security issues and all kinds of fault tolerance problems that you're going to have to deal with. So you want to keep it decoupled, and then at application layer continue building these more sophisticated protocols. Almost like TCP on top of, UDP IP type of things, right? Or HTTP, which gives you encryption on top of unreliable communication. And so that's at least the way I think it needs to be approached for the blockchain space. Otherwise, we're going to be mixing things up and run into the security issues for forever.
But I think what you're saying here is like that sort of MEV would be like on either side of Axelar, right? Like when you're moving funds from one chain to another, you could be like front running or doing something. I don't know what it is. But could there be within Axelar any issues? Like within the validator set, like is there any benefit to a validator putting forward, or like, I guess it's hard in proof of stake, but like is there any game that could be played on the validator side within Axelar in this context?
Potentially, I mean, I'll have to think a little bit more, but those are the things that you can protect against, using like threshold encryption and decryption techniques. So I guess on the Axelar network, I'm not too worried about this. I'm more worried about now this multi-chain interaction, right? Where you can have potentially messages from different, source chains that get, delivered to the destination chain, and you can have all kinds of, race conditions between them and all kinds of MEV. Yeah. So I think that would be a lot more complicated to protect against than like on the Axelar network, which I think is pretty straightforward.
Got it. What is the speed of this movement across in the case of Axelar? You sort of mentioned that it's fast, but I'm wondering, a direct multi-sig one-to-one, like chain to chain with a multi-sig on either side seems like it would be the fastest. It might be expensive because you'd have to like unlock on one side, especially if it's like Ethereum with very high gas prices. But is there any sort of delay or lag by going through this kind of system?
I mean, not really, right? I mean, I think in that case, kind of the performance of multi-sig and kind of centralized implementations and the performance of Axelar will be pretty comparable, because what you need to do, you need to make sure the request on the source chain is finalized, right? So that's subject to the rules on the source chain. So if it has instant finality, you wait, let's say, for 5 seconds, right? Or for 1 second. From there, you need this set of validators to process this message and, translate it or execute it for the destination chain. For the Axelar case, it is built around the Cosmos SDK. So we have kind of 5-second block finality, right? So it's kind of pretty efficient, and you can do things, in an optimal way, maybe, in a couple blocks, right? And then from there, you just take the message and you post it on the destination chain, and there you're subject to the, latencies of the destination chain. I think as all of the systems are going to be improved and like the latency go down, you're effectively adding, another hop of a proof of stake network in the middle, which I think can be reduced. And, down the line, definitely we're looking at kind of sub-second finalities.
So one question that came up on a previous episode, Tarun was supposed to be on this one, but we moved it around and he unfortunately couldn't be here. But I feel like he would ask this question, which is, say you're bridging some stablecoins to, I don't know, Solana or something, and other bridging technologies, other interoperable kind of pools are also bridging their own synthetic stablecoin over to Solana. Now you have like the same ones, but they have different names, but you're kind of dealing with like the same underlying assets. What are you thinking about with that? Because I know this is a space that people are kind of worried about, like potentially there being I don't know if it's like just crazy arbitrage or if there's some attack somehow in there. I'm curious to get your thoughts on it.
Yeah, so I think it's a kind of a general problem of kind of fragmentation, right? And liquidity fragmentation, where you can have a situation where you have multiple assets that represent potentially the same thing, right? But they call differently, they have different contract addresses and so on and so forth.
And they could have different liquidity.
Different liquidity.
Could affect the price.
Of course,
like, would
absolutely.
you almost be able to arbitrage stablecoins, even though they should be all close to the same amount if one is... Actually, how would that work? If one was more rare, if one was like had lower liquidity, would its peg would it break upwards? I mean, like a stable coin?
When you have lower liquidity, I mean, one of the examples is that if you then uses like in a DEX pool, right, that users are going to have to tolerate more slippage, right? That's a very simple kind of example. One of our investors, actually, Steve McKean, he recently wrote an article of what happens when you have this liquidity fragmentation across ecosystems, and what is the benefit of unifying it and kind of merging it together, right? And so I think there he actually very clearly demonstrates some of these precise kind of points where if you have different liquidity pools, if they're smaller liquidity pools, then users suffer at the end of the day, right? And so what you want to end up having is like unifying them in some sense, so there's a deeper pool and users can pay lower transaction fees and have lower slippage, right, in this process. So going back to your question of liquidity fragmentation, what do we think about it, and what are some of the approaches to deal with it? So I think actually an important question that we'll be answering over the coming years as we get robust interoperability and more general message passing is whether an asset will go to a compute environment or a compute environment will come to assets. Okay, so think of it this way. Right now we're moving, tokens back and forth through these centralized bridges for the most part. That we're moving assets, right? But you can do it the other way around, where you can have a program, right, a smart contract code, and if you need to execute something with respect to these assets, you make a call, right, to a chain where there's the deepest liquidity of this asset, and then that call gets executed on that chain. The state can be reflected there, and the state can be propagated to other smart contract or other users on different chains, and they all get a unified view of that state. So I think as we get robust interoperability stacks and as we get this general message passing, this will be one of the questions. And I think there are various trade-offs depending on how you design an application to either move an asset or move the compute closer to the asset.
Would it be like you'd have one high liquidity asset? Let's use like it could maybe still be a synthetic, but it's some sort of like, for now, it would be like I don't know if there is already this XUSD. Is that going to be yours, by the way? Is it going to be is that the name of the?
I think we're now adding a prefix AXL to our assets. Okay,
AXL, not X. Yeah. Let's call it like ZK. So it's like the ZK USD. Okay. Yeah. So this is theoretical. So if there's a ZK USD pool that's high, like there's a lot of liquidity in there. The idea here is that instead of trying to move it over to the different ecosystems, you'd keep it there, right? Like you'd keep it on that chain in that format in the largest pool possible. But if you wanted to interact with it, you'd send messages over this chain. But that's not how it is right now. Like that's not how it works.
It's not, because there's no interoperability right now across the ecosystems, right?
But right now what's happening is like you are sending the tokens around. Do you think that there will actually be a move towards just having the single pool on one chain that's like that? Is that sort of a prediction, or is that something you're actually seeing movement towards? Because I think it's going the opposite direction right now, right? Like right now, tokens are getting sent all over and everyone's creating their own synthetic.
Yeah, so I do think it's going to get sort of unified and abstracted away from the users, okay? And I think there are various ways of doing this. I think, I don't think I would predict that, there's going to be one asset on that chain and you have the deepest liquidity and it's not available anywhere yet. But I think depending on the use case and depending on the application, one model or the other could make more sense, right? So let me give you like one example. Suppose you have an NFT, right, on Solana, and you want to take a loan against it on Avalanche, okay? So in that case, maybe the loan that you want is in the most liquid stable coin on Avalanche. Let's call it, I don't know, UST, for example, okay? But your NFT, lives on Solana. So what you can do is you can lock it in a contract on Solana. You can deliver a message to Avalanche that says, this NFT has been locked. This is the user's address. Please give a loan to this user against this NFT. This is the duration of the loan and like all the parameters, and this is their address. So in this case, you don't have to transfer the asset. The asset remains where it is, but you just passed enough information and you obtain, an asset that you deserve or desire on a different chain, right? So this is one example where you don't actually have to move it. You just need to move sufficient information about it. And I think for different use cases, we'll have to iterate like one by one where it makes sense what.
I think the work you kind of described before suggested that it would be good if there was like deeper liquidity pools, but like single assets of one kind. But yeah, are there any strategies being taken by any networks to actually encourage that? Like, could they ever block? Probably they can't, but like, is there any way to, I guess you could highlight one, but like, yeah, is there any way to decide that there is only going to be one canonical version of something on a network?
Yeah, so there are actually a couple of efforts towards that. And I think Frax is a good example of a stable coin, right? And sort of the way that it works is that the team has a canonical representation of Frax on different chains, and they authorize different, say, bridge providers, right, or interoperability providers to swap their tokens for the canonical representation of this asset, right? So in that case, all the applications would only list and interact with this canonical representation, and maybe they authorize sort of one or two different paths of routing or delivery of those assets to that chain. And I think that's definitely one of the trends that we're starting to see right now is that unification at like an application layer where you now trust effectively multiple underlying interoperability stacks to execute messages on your application specific contract that just mints this canonical representation of the asset.
I'm wondering, like, how do you actually deploy Axelar onto new networks? What is the action for you? And maybe actually, before we do that, tell me, where are you now? There was an announcement that you're kind of bringing atoms to Moonbeam, I believe. And I thought that was kind of crazy because it was, for me, at least the first time, I'm like, oh my God, there's actually, it's there. Yeah. We've heard about this for a while. But yeah, so tell us where you are at. And then I want to hear about like how to add more.
Yeah, so where we're at, we effectively started the main network rollout, which is a phased rollout where different functionality will go live on the network over the subsequent months. Currently, we connected, I think, something like 10 or 11 chains through the Axelar network. Some IBC chains like Cosmos Hub, Injective, Osmosis, Terra, and then a bunch of EVM chains like Avalanche, like Moonbeam, like Ethereum, like Polygon, and we enabled various kind of asset transfer use cases around the network. So you can move things like UST, you can move Atom, right, which I was really excited about, to different EVM ecosystems and actually, use it as an on-ramp to get back to Cosmos, right? So now users can finally get the Atom and go back to Cosmos without having to go through a centralized exchange. And there are pools like on Uniswap, right? There are pools on Moonbeam that have been created. So super excited about that. And in the coming months, we're rolling out more functionalities. So kind of the general message passing is going to go live over the coming weeks on the main network. We have lots of applications that are building in this new environment and kind of building their cross-chain applications. And yeah, the goal for us is to connect million chains, right? Millions of chains down the line, and that requires a very thoughtful approach how to scale and how to scale horizontally. Yeah. And we'll tell more about that in the coming months.
How do you actually set up on these new networks? Like, what are you actually doing on each side? Are you thinking in pairs of two networks connecting between two networks? Or are you just like, we're adding a new network to our input and it can go anywhere after that?
Great. So never in pairs. I think, the pairwise approach is, again, adds to this fragmentation and liquidity, divergence. So yes, you onboard to the Axelar ecosystem, and from there you get connectivity to everything else that's been previously connected. So huge networking effects and huge compounding effects, right, from that. The way that it works is kind of depends on the ecosystem. So we support multiple protocols, right? We support IBC because everything is around Cosmos SDK. So to set up, IBC channel, it's pretty straightforward, like 10, 15 minutes, and you set up relayers from there, right? Similarly, we've done everything almost as easily, maybe a little bit more complex, but in a similar fashion to set up connections with EVM chains, right? So to connect an EVM chain, we deploy a gateway contract there. The validators register to vote on events from that chain. So they would have to query like a light node or a node of that chain. And then a sequence of commands needs to be executed on the Axelar network to register that chain and kind of create this path to this new chain. Once that path is added, the information can flow to all the other ecosystems that have been previously connected.
But who does that? Is that your team that's doing that? Or is that potentially like external participants who are like, I want my chain to be also hooked up?
The goal for us is to make this permissionless, right? And so anybody will be able to do this. For now, it is a kind of governance, right, of the chain, and like a number of folks have to authorize and kind of co-sign the message to be executed on the network. But yeah, down the line, the goal is that anybody will be able to set these things up. You'll be able to create a connection in an easy way and just talk with other ecosystems from there.
Do you not end up with that problem? This is like an old problem that I think I highlighted on the first interview I ever did with Sunny. It was about like, what if one of these chains is super, super toxic and it's not functioning correctly? Potentially like there's a consensus, what do they call it? It's been captured. So like 51% attack or 66% attack if it's proof of stake. And like someone's just printing money using Axelar to send these funds elsewhere to trade them. How do you actually prevent that in a totally permissionless way, like in a permissionless system, rather?
I mean, I think it's a great question. So I think a couple answers to that. So first of all, I think that's why it's important to understand that whenever we're talking about cross-chain or interoperability, minimizing the number of hops to get from a source to a destination is critical.
Okay.
Right? I think like a lot of people have this, view that the blockchains are going to be connected in exactly the same way as like intranet and peer-to-peer networks, right? On the intranet and peer-to-peer networks, your packet takes, 10 to 20 hops going from a source to a destination.
Oh, true.
In a blockchain world, that would mean you have to make you have to assume 20 networks are trusted as your packet goes from a source to destination, which is ridiculous, right? Mm-hmm. So I think minimizing the number of hops is going to be a key point. And then two, that's why you want to route and deliver your information through networks that have been designed to deal with situations like this, right? And dealing with situations like this, you can have, a number of on-chain and off-chain protocols in some sense, okay? So on-chain protocols, if the chain is malicious, validators, can go and, just disconnect their RPC endpoints, right? Or disconnect their relayers and stop processing the message from that chain, right? You can also have kind of off-chain governance where, a committee has to come in and sign a message that pauses transfers in and out of that ecosystem, right? Or pauses the state of that chain on all the other chains that it's been connected to, right? So having a place and an interoperability network that deals with some of the situations is also quite important, where you have these rules and you're thinking through them. Because at some point, these things will happen, and you have to have, again, a combination of kind of on-chain and consensus logic that you can deal with, and also off-chain, I would say, kind of a mechanisms to prevent some of these things.
Yeah. I mean, the governance idea definitely sounds like it sounds like you could halt it, but could you undo it? Not really, right? Or I guess, no, actually, no, you can't, because they live on, at this point, like those assets may have traveled onto other networks that your validator set would have no control over.
Yeah, I mean, the reality is that I think undoing any of these things would be, I think pretty hard, right? It's no different than there is like an exploit in a smart contract on Ethereum, and somebody managed to steal funds, and then they, execute in 5 minutes and like route it to all the other DEXs and centralized exchanges and try to get their money out, right? So
you feel like there's other places you could stop this?
I think some of these things will have to come kind of at an application or on and off ramps in some sense, right? Where, as an application, you can always kind of delist an asset, for instance, right? If you don't trust it anymore.
Totally.
If we're talking about this canonical swapping, right, where multiple bridge providers potentially swap to a canonical representation, you definitely can, disconnect one of the paths. And again, from there, if it already traveled through the swapping mechanism, then the applications and like on and off ramps will potentially have to deal with it and, exclude the asset or some of the accounts. So I think it's no different than like, a bug in a DeFi application in some sense, that kind of similar strategies will have to be taken.
On Axelar, it's not a smart contract platform itself, but like, would you ever imagine a DEX living on you? Or do you always think of it as living on the sort of native chains?
Our goal is to empower developers to build anywhere they want, right? And that means like giving them tools and giving them APIs to go and build on the best platform that's optimized for their use case and optimized for their need. We optimize Axelar network for interoperability, right? And for routing and for all these functionalities. So, I can't, I guess, predict the future, but I think in some sense, the network has been designed with the different goals in mind, right? And our goal is to help scale the ecosystem and empower really developers to make the best choice for themselves. And I think through interoperability, you get that.
A few weeks ago, we had Georgios on the show talking about Foundry and sort of testing across. And one of the topics was this multi-chain. How do you test across them? I don't know if this is like your problem, but I'm wondering if you think about it, because it's obviously like you're just providing the way to move between. You're not necessarily saying that like chain A should be tested this way versus chain B. But yeah, I'm wondering, like, do you offer recommendations to teams who are trying to develop across two networks?
I mean, we're definitely going to provide, examples, right, and like a framework. I think I do think in some sense, it is our responsibility, right, as a kind of the team that's doing a lot of work in the space to help developers think about cross-chain and multi-chain world and how to do these things. One of the key core differences is that everything becomes asynchronous communication all of a sudden, right? And so whenever you're dealing with this asynchronous communication, you have to think about what happens if the transaction doesn't go through on the destination chain, right? What happens if it gets reverted? How do you deal with kind of fallbacks and things like that? So I do think we're going to be adding, examples. I do think we'll provide, testing frameworks and way for the developers to think about it. And I think it'll be a collaborative effort between our, developers and our team to kind of get there.
Cool. I mean, a big topic that I think has come up is this idea of just the arbitrage or hacks, actually. Like, this is where this question kind of comes from, is given that there's been some very high profile, very large problems, specifically, I mean, I think Wormholes was the largest and most recent, and that was like a pure bailout. It wasn't returned by the hacker. Sometimes you have these hacks where it's like, it's a hack, and it's like, just kidding, they gave it back. But yeah, in that case, it wasn't. So what are you thinking? Like, are you not worried that you could fall into the same trap? Do you feel like there's some sort of thing about your system that protects you better?
So I think there have been actually more hacks, right? After the Wormhole, there was the hack on the Axie Infinity blockchain, right? That I think like 600 million.
Which was also a bridge, yeah.
Which was like a bridge, again, like a centralized bridge ran by a couple of folks. So I think this is one of the most important problems to solve, right? In some sense, is build a secure infrastructure. And I think you do have to have a strong base for a decentralized protocol, right? So where, again, I think everything comes down to building a kind of a permissionless system where anybody can support your protocol, right? Anybody can participate, having the code open source, like people auditing it, people inspecting it, multiple participants kind of contributing to the security of the network collectively, right? In various formats, either by running validators or looking through the code or, testing things. So I think that's critical, and that's, I think, quite important. And that's sort of the base of, what we're doing at Axelar. And from there, I think it's a combination of, the right designs, right? The right architecture, the right engineering practices, kind of code audits, and being very thoughtful about everything along the way. I think we're in the interoperability, we're kind of in the same phase where we were about, a year in DeFi developments, right? Like people hacking left and right, everybody rolling out their, DEX, everybody rolling out their, borrowing and lending application, like everybody kind of races for the market and doesn't care too much. And so I do think it can be done, secure. I do think it can be done well, but it is kind of technically probably the hardest problem we're facing right now. But that's what makes us excited every day. So
I'm also just curious about how do you incentivize like the validators actually in this context? Because it's not like people are using it for, I'm just curious, like how are the fees working? Are you earning the fees from each network and then translating them into the Axelar token? I'm just curious how that works.
Yeah, so the way we build the, at least some of the functionality around the token and the kind of general contract calls is that you always pay in one transaction on the source chain, and then the set of services takes that transaction fee and then converts it to pay transaction fees like on Axelar network or on the destination chain.
I see.
And then, if there are excess transaction fees, they can go back to the community pool or the validators of the network and things like that. But from a user perspective, it's super simple. You pay, in the asset that you want on the source chain, either a flat fee or it's sort of dynamically calculated, and all the other relay fees and the network processing fees are taken care of for you.
How are you bringing that into because you're not a smart contract platform, like you're a blockchain that just has that one native token, I guess, right? And then just is doing the work of passing this information through itself.
There are multiple ways to bring it. You can always have kind of a proxy contract on the source chains, right, where the funds are locked for the transaction fees. But B, we do actually treat the tokens as sort of almost like a first-class citizens through Axelar network, right, for the purpose that we want to be able to kind of translate them to IBC messages, right? That's one of the examples. So you can actually have a representation of the tokens that you move in, sort of minted on the Axelar network as a standard kind of Cosmos denomination, right? And that asset can be dispersed to the validators or used to subsidize all the other transaction fees. So there are multiple ways you can deal with it on the source chain, Axelar network, destination chain. It just kind of depends on the trade-offs.
Which of the networks would you say you're closest to? You've mentioned Cosmos a bunch of times, obviously Ethereum, but would you say that your focus right now is at looking at the Cosmos ecosystem, or are you looking at other networks as well?
I think definitely kind of given the technology rollout, I think, and given what we've done, it's super easy for us to onboard any Cosmos chain and any EVM chain, right? And almost be one of the hubs across those two ecosystems of EVM chains and IBC chains. And that's why we have kind of half a dozen connections across each one of those. But, our goal is to be able to connect everybody right down the line. And so we have kind of a path how we expand and how we grow the network. Cosmos to me, in particular is, I think I have a lot of respect for, the ecosystem, for the technology that's been built. I think it's been one of the, most valuable stacks, I think, that allowed people to innovate. And definitely the community itself is very focused on interoperability, right? And I think that's that what allows all these networks to sort of talk to one another and have compounding effects and actually collaborate. So I really enjoy kind of working with the Cosmos folks.
Do you have plans to potentially deploy on Osmosis soon?
So we actually submitted, a proposal, right, to the Osmosis team for supporting kind of bridge functionality for them. There have been a few other projects that have submitted the proposals. I think, the team's been evaluating, and we had some kind of online panels that we talked about.
I saw that. I really liked that, actually. It was so interesting. Sunny was hosting, and it was 3 hours long, but it was great. It was it's basically, I'm doing something similar, but episode by episode spread out over months. He did it in 3 hours. So we'll link to that if people want to sort of front run me, hear who I'm going to interview next. But anyway, cool.
Yeah. So, I think, Sunny and the team, I think they kind of publicly said that they think kind of Axelar approach is the best technologically, what provides for Osmosis. It's still going to be a subject to a governance vote by the Osmosis community. So we'll kind of wait and see what happens there.
What about Polkadot? You just did the Moonbeam deployment. Would you be interested in anything else, or did you do that primarily because it's EVM and it's something that I guess you have Solidity contracts, or you have some template that's somewhat easy to deploy to EVM. But are you looking at other parachains?
I think for us, Polkadot ecosystem is kind of forget the technical differences, but I think very exciting because of the connectivity and interoperability they have within their own, ecosystem. So that's why, we connected with Moonbeam. There are a couple other big parachains that I think have EVM compatibility. So we'll kind of see what happens there. And I think we'll also see how a lot of the traffic is routed, right? Is it going to be now, suppose you go from a Cosmos to Polkadot, right? That's like IBC, then Axelar to EVM to, another message format within,
I don't know if that's a message format actually, but anyway.
XCMP or what do they call it?
XCMP. Oh, yes.
Yeah, something like that. So yeah, and then that message format. And so, I think it'll be quite interesting. So one of the next steps for interoperability in general would be to build this kind of protocols on top of the core pipes in some sense, right? To make it easy for all these end-to-end flows for the users and applications. So I think that would almost require like a service layer above the network to make some of these things easier and multi-hop routing in particular.
And what about Ethereum and the L2s? This is sort of my last kind of question on networks. Like, yes, they themselves are kind of like, they have kind of mini bridges to the main chain often, but yeah, would you imagine bridging between the L2s?
Oh, for sure, right? And, I think a lot of them have asked for it. And, so we're connected to Polygon, right? And I think we'll connect to, a bunch of others as well. I mean, I think Ethereum, in some sense, is becoming like another interoperability hub, right? Where you're seeing a lot of the applications, migrate from the main chain to one of these, L2s, right? Or side chains. And then Ethereum, what does Ethereum get you? It gets you, security and message relay and transport layer in some sense, right? So, but it is a very expensive layer, right? No matter what, the transaction fees are there, still ridiculous. We'll see what happens with the proof of stake migration. In that process, having Axelar as the proof of stake network already, right, allows you to do similar types of functionalities, but in a much cheaper environment.
So I want to ask you a question about zero knowledge and sort of the actual ZK as validity proof. Do you have ZK in your stack anywhere? Or do you have plans to have it?
I mean, not directly, right? Indirectly, ZK is used like in some of the threshold libraries, right? In threshold cryptography to prove certain statements. Directly, I think it would be quite interesting to use it potentially down the line, again, for the purpose of optimizing some of the validation, semantics, right? And transaction sizes. So instead of having validators compute either multi-sigs or threshold cryptography, you can think of creating a zero knowledge or a proof, right, that the validators have validated a certain message on the source chain at the sort of consensus layer or in smart contracts, and then relaying that proof to different chains that we connected with, and then just validating it there, right? So I think that would be quite interesting. I think that would be definitely one of the directions to get us to many hundreds or even thousands of validators, depending on how optimal you can make this zero knowledge or proofs, and how efficient you can make the validation logic, right? Definitely something I think worth exploring. And I think the second direction, which I'm super excited about, is actually working with privacy preserving chains. Right.
Yeah, that was actually my next question I was about to ask you.
Great.
It's like, what about the privacy part? Because we talked about a bit like the use of the cryptography, but yeah.
Yeah, so super excited about that. We actually just a couple of days ago announced a partnership with Manta Network, right, which is on Polkadot that uses some of the zero knowledge techniques to get privacy. And it's super exciting to me because it enables you to send information, let's say, to a privacy preserving chain, almost like to a black box, do some stuff with that information, right? Like manipulate it, process it, compute it, exchange it, and then you can come out, on the other end, right? And like continue sending your assets or your information to other ecosystems. So I think it'll be a really exciting direction to see these privacy preserving chains connected to other ecosystems.
Would you ever be able to provide privacy within Axelar? I mean, I guess not really. If it comes out the other end, it's sort of public, but yeah, I don't know if you've been thinking about that. Maybe, or between two privacy chains, maybe is another way to think about it.
Great question. So I haven't thought about it too much. I mean, again, in some sense, it's a proof of stake network like any other. So if you wanted to apply privacy, okay, you have to do like research, what other people have done, kind of what works in the Cosmos stack and with its Merkle tree implementations and all that stuff. And so you can definitely apply it if you wanted to. And, I think I'll have to think more.
Yeah, I mean, I guess Penumbra for Cosmos SDK, they're definitely working on some privacy things.
Right.
It's something to check out. But in terms of that, going across, I just sort of want to keep thinking that, like, so far, right now, if you wanted to move from one chain to another, you basically have to decloak to do it, right? Like, you have to unshield. That's what we should be using. Cloaking, like Star Trek. Why do we use
Nice.
shielding? Sorry, just had a thought. But anyway,
I love it, yeah.
like you'd have to basically unshield the asset and then ship it over. Like there's no way right now to keep it private into the bridge, because I guess you need to know the amounts and where it comes from, and like there's probably too much info that isn't yet made, you can't yet make private.
So yeah, right now there is no way. I mean, I can think of a couple ways of doing it. So for instance, if Axelar network supports kind of a MPC protocols, right, then you can have a protocol where instead of actually, unshielding your transaction, right, maybe you communicate, you share a secret key to the Axelar validators that allows them to privately decrypt the transaction amongst themselves. Nobody has the transaction clear, but it's sort of a secret shared across all of the validators, do their necessary functions to validate it, right, and compute a message that needs to be posted on the destination chain in a shielded way. Right, so I can definitely see, theoretically how this would work. Practically and engineering-wise, I think it would be quite an interesting project to do.
Cool. I do have one last question, which is a little bit about the competitive landscape. We started with that, like I mentioned that like yours was the first project that I'd really understood to act that way. But since then, there's other projects that maybe even existed, but I didn't understand them as being sort of this multi-asset interoperability play, but there are new ones. How do you think about those? How do you see yourself as different from those? Or do you see these projects sort of all kind of headed towards this very similar architecture?
No, not at all, right? I think, you're still continuing to see a lot of pairwise solutions, which I think, have scalability effects and kind of fragmentation issues that you're going to have to deal with down the line. B, I think a lot of the protocols, and there's a number of protocols that have been proposed that kind of rewrite and change the name of things and kind of obfuscate it, and actually doesn't add anything to the security of the cross-chain or interoperability. I think building a decentralized interoperability protocol that works across different stacks is, again, like very challenging, right? I think it's a very complex technical problem. I think a lot of people are taking shortcuts along the way to get to the user experience that I think we've been describing for the last year, right? And like pioneered in one of the white papers that we wrote with the gateways and kind of communication across them. You can get to that user experience in a, with centralized backends in some sense, which I think is a mistake, and you're going to be run into the security issues. But getting to that user experience with a decentralized backend, I think, is a very complex kind of a problem.
Of the other solutions, this is a kind of a funny question I've never asked anyone else, but I'm curious how you'll answer it. Which is your favorite? Which is your favorite of your competitors? Who do you think is like really good? I'm going to try to ask everyone, all the bridging people this.
Great question. So,
yeah, because you don't want to say. It's such a hard one.
It's a hard one.
Wormhole? Nomad?
No, I think Wormhole is a centralized bridge for all practical purposes, right? Nomad, I think, explores interesting trade-offs in the safety and liveness assumptions, but I think from a safety and decentralization perspective, it's a step backwards in some sense, because I think, they introduce liveness assumptions to guarantee safety, which I think is very dangerous for the cross-chain world, given like all the attacks that we're seeing in the space. There's not a lot of research on this, right? On this interoperability, at least protocols that I would consider any sound or any any truthful. I think there's a lot of marketing material and heuristics proposals out there by some people that don't understand anything about basic liveness and safety properties and trying to market, and go to market with them, which I think is a huge mistake. So I actually would love to see more rigorous analysis on the safety and liveness of the protocols and on the trade-offs and the distinction between permissioned or permissionless systems, which is not something we're seeing a lot in the space. So I would say, it is a hard technical problem. I think a lot of the teams are doing, the best that they can to solve it. But I think we have, the best and the most decentralized approach and the most universal approach that I've seen to date. So.
All right. Well, said like a true businessman. All right. But I'll take it. I am gonna try this potentially with other interviews, so they can get prepared for that question of who of your competitors do you like the most. Well, listen, Sergey, thanks for coming on the show and sharing with us this sort of story of Axelar, the work that you're doing, what makes it unique, and where you're at. I think it would be really cool to hear kind of what's coming next, and then I think we'll wrap up. So what is coming next?
Yeah, continuing the network rollout. So various features will go live, like, general message passing will go live right on the network across EVM chains. And then we, looking at how to extend it to Cosmos chains as well. So I think that's going to be, super exciting. More connections, right, to more networks that are not connected, more applications integrated on top of the network. So we have a huge pipeline of everybody from cross-chain DEXs, NFTs, wallets that are building around the network. So I think that would be, super exciting. And I think the goal is to get us to a world where people or users don't have to think about multi-chain, right, or cross-chain. I think these things have to be obfuscated and taken away from the user interaction. So to me, that's the biggest goal, and that's the biggest, point to work towards.
Cool. Well, thank you so much again for coming on the show.
Awesome. It was great being here, Anna. Thanks.
I want to say thank you to Tanya, the podcast producer, Henrik, the podcast editor, and to our listeners. Thanks for listening.